Here we have a model, another formula that compares someone's weight and height after they've reached a certain height. And this is a relationship that the data has shown, which proves, or not proves, but was able to provide a model. Well, this model is solved in a particular way, but how it's going to be useful for me is if it was solved for W. So how do we do that? Well, first of all, I think you recognize that it contains a fraction. And you might remember from before, well, how do you deal with a normal linear equation that had a fraction? We looked for a number that was our fraction eliminator. So I'm going to look at the denominators of all the variables or all the terms and use that as my lowest common denominator. I see that I have a 2. So imagine what would happen if I multiplied the left side by a 2 and the right side by a 2. I distribute the 2, so I have a 2 times my first term. I have to distribute the 2 to both terms, so now I have a 2 times a 3h equals a 53 times a 2. Let's clean that up a little bit. 2 times w over 2, the 2's factor out. I have a w minus 2 times 3, which is a 6h, equals 53 times 2 is 106. What was my goal again? Well, first of all, I guess I lost track because I was so excited. There's like no fractions here. I still don't really get why we do these because they're just variables. But then again, I have to stop and think, oh yeah, these variables represent a formula which represents some type of relationship we discovered in real life. And so my job now is to manipulate these formulas around so the nursing department or the economics department can use these for their benefit. Our goal was to solve for W. Isolate the variable, so let's remove the other term. So I have W minus a 6h. To remove that 6h, I'm going to add a 6h to both sides. Simplify, I'm just left with a W equals 106 plus 6h in this particular case. My result doesn't look any less simplified. All it is, it's in a different form. Originally, it was solved in this particular form. This form, we just solved it for a particular variable, W. We could have solved it for H if we were asked to. In this case, we were asked to solve it for W. So it's just rearranged, algebraically true, just into a different form.